Talk entropy. Entropy is sort of a measure of order and disorder. So let's think about this in terms of poker. All right. What's more likely, an ordered state, meaning something crazy like a royal flush, or a disordered state, meaning having no pair or one pair? All right. And we know if anytime you've played any kind of poker or any kind of cards, disordered states are much more probable. It's really easy to get a hand that doesn't have any significant pairs, okay? It's really hard to get a hand that's like a royal flush, okay? So entropy measures disorder, and entropy measures the probability that a particular macrostate will occur. So here, up here, this is increasing order, right? These things are all lined up. That means that's less entropy, and it's less likely that this is going to happen. Down here, this is pretty random. That means there's more entropy, and it's more likely that this is going to happen, okay? So the second law of thermodynamics, most formally, says the entropy of an isolated system always increases until the system reaches equilibrium, which means if we have this ordered low entropy state, if you take the wall away, this will eventually become something like this. So this is a disordered or higher entropy state. This would be the most likely macrostate. This would be equilibrium, okay? And that would sometimes mean thermal equilibrium. So the second law of thermodynamics means the entropy always increases until a system reaches equilibrium. And what that can be stated as is heat never spontaneously flows from hot to cold, okay? Remember, heat always goes towards, never spontaneously flows from cold to hot. Heat always goes from hot to cold, okay? So here's a question. If a supersaturated sugar solution is allowed to slowly evaporate, we get sugar crystals that form, okay? So sugar molecules go from a solution, a very disordered state, into a highly ordered crystalline structure. And we want to know, does this process violate the second law of thermodynamics? Okay, so think about that for a minute, and then we'll talk about it.
We're basically just dealing with sugar and water. And the thing that we have to remember here is the system includes water, right? Not just sugar, and it's initially in a liquid form, which is a pretty low entropy state. Later, it's in a gas form, which we know is a very, very, very high entropy state, right? So it's moving all over the place, it's moving very fast, especially if you're heating it up so it boils off. So the increase in entropy of the water has to be much larger than the decrease in entropy of the sugar. So overall, the system's entropy is going to be just the same.